Hello everyone, my name is Matthew. I'm a math teacher. In this video, I'm going to talk about a basic topic of mathematics called factorization of two terms only. You may stop this video, try by yourself before looking at the solution. Let's look at the following questions. The first one is to factorize 7a plus 7. A basic rule of factorization is to take out common factor of all terms. Obviously, in this question, 7 is the common factor. So we take out 7, then we give a bracket. Inside the bracket, because 7 divides 7 is equal to 1, it becomes a plus 1. This is similar for the second question. We take out 7, then write down a minus 1 inside the bracket. Now we look at question 3. We take out 7 again. This time we write down a squared plus 1 inside the bracket. For question 4, which is similar to question 3, but we change plus to minus. Have you finished? No. The first 3 questions are easy, but this one is relatively tricky. Let me introduce an identity about the difference of the squares, which is a squared minus b squared equals a plus b, or multiplied by a minus b. 1 can be written as 1 squared. If we treat b as 1, a squared minus 1 squared can be factorized as a plus 1, or multiplied by a minus 1. Then we look at question 5. Take out 7 again. It becomes 7 times a to the power of 4 plus 1. Let me ask you the same question. Have you finished? This time the answer is yes, since we don't have any identity to factorize this expression. But for question 6, the situation is not the same. After we have factorized 7 out, we can write a to the power of 4 as the square of a squared. Then give square to 1, so it has the pattern of a squared minus b squared, and we can treat a squared as a. In this case, we can factorize it as a squared plus 1, or multiplied by a squared minus 1. The same question again. Have you finished? Sorry, no. For a squared minus 1, we can further factorize it as a plus 1, or multiplied by a minus 1, and then copy the remaining on the left. Will it be the same when the power 4 is changed to power 8? Yes, for 7a to the power of 8 plus 7, just need to take out 7. Then we finish. The first step is the same for question 8. We take out 7 again. For a to the power of 8 minus 1, it can be changed as the square of a to the power of 4 minus 1 square. By using the same identity, it can be factorized as a to the power of 4 plus 1, or multiplied by a to the power of 4 minus 1. Then it is the same as question 6. A to the power of 4 minus 1 can be factorized as a squared plus 1, or multiplied by a squared minus 1. And we copy the left part. Finally, a squared minus 1 can be written as a plus 1, or multiplied by a minus 1. And write down the remaining again. We use the same method when the power is doubled to 16. For addition, we need one step only. While for subtraction, we need one more step, and the answer has one more bracket than question 8. In addition, we can see that only the last bracket contains minus sign, while the others contains plus sign. This is one of an interesting pattern for factorization. Next 2 questions contain a quib. For 7a quib plus 7, we take out 7. Inside the bracket, it becomes a quib plus 1. Let me ask you the same question again and again. Have you finished? The answer is no. Now I introduce another identity about the sum of the quibs, which is a quib plus b quib equals a plus b, or multiplied by a squared minus ab plus b squared. 1 to the power of anything equals 1. Therefore, 1 can be written as not only 1 square, but also 1 quib. Hence, the answer should be 7 times a plus 1, or multiplied by a squared minus a times 1, which is a, and then plus 1 squared, which is 1. When plus sign is changed to minus sign, we still take out 7. Then use another identity called the difference of the quibs, which is a quib minus b quib equals a minus b, or multiplied by a squared plus ab plus b squared. same as question 11, we change b to 1. So it becomes 7 times a minus 1, or multiplied by a squared plus a plus 1. These two questions involve a to the power of 6. After we have taken out 7, since a to the power of 6 can be written as the quib of a squared, and 1 can be written as 1 quib. By using the identity of a quib plus b quib, it becomes a squared plus 1 squared, or multiplied by the square of a squared minus a squared times 1 plus 1 squared. So the answer will be 7 times a squared plus 1, or multiplied by a to the power of 4 minus a squared plus 1. Now we look at question 14. 7 is taken out again, and change a to the power of 6 to the quib of a squared. If you use the identity of a quib minus b quib and the same method as the previous question, it becomes 7 is multiplied by a squared minus 1, or multiplied by a to the power of 4 plus a squared plus 1. This time we haven't finished, as a squared minus 1 can be written as a plus 1, or multiplied by a minus 1, and then copy the rest. Unfortunately, this is not the best answer. It is because 6 is the common multiple of 2 and 3. If we exchange the position of the power 2 and power 3, that means we can write it as the square of a quib minus 1 square. We can use the identity of a squared minus b squared. Then the next step becomes 7 times a quib plus 1, or multiplied by a quib minus 1. Inside the first bracket, we can further factorize it to a plus 1, or multiplied by a squared minus a plus 1. For the second bracket, it becomes a minus 1, or multiplied by a squared plus a plus 1. Comparing with the previous one, if we underline the difference between the two answers, it is easily to see that the right part contains one more bracket, and we can treat a to the power of 4 plus a squared plus 1 can be factorized as a squared minus a plus 1, or multiplied by a squared plus a plus 1. To prove they are identical, we can expand the right part to check whether it is equal to the left part or not. It is necessary to multiply each term inside the first bracket by each term inside the second bracket. A squared times a squared equals a to the power of 4. A squared times a equals a quib. A squared times 1 equals a squared. Negative a times the term inside the second bracket becomes negative a quib minus a squared minus a. 1 times the term inside the second bracket becomes a squared plus a plus 1. After that, we cancel out the same terms with opposite sign. Obviously, a to the power of 4 plus a squared plus 1 is obtained. Therefore, the right part is the final answer. Last but not least, the powers of the last two questions are doubled again. We use question 13 and 14 as the references. For addition, we will write a to the power of 12 as the quib of a to the power of 4, and use the identity of a quib plus b quib to finish the factorization. For subtraction, we express a to the power of 12 as the square of a to the power of 6. Then just like question 14, we use a squared minus b squared equals a plus b, or multiplied by a minus b. So a to the power of 6 plus 1 and a to the power of 6 minus 1 are obtained. If you still remember, they are just question 13 and question 14. We only need to copy the answer of these two questions. Therefore, we can finish question 16 easily by using the previous results, so that we can prevent to write down those complicated steps. To finish, let's go over the main points again. There are several steps to factorize an expression. First, we factorize the common factor. Second, if the expression inside the bracket measures a specific identity, we use that identity to factorize again. Finally, we need to check for each bracket, factorize again if some of them match any identities, until all of them cannot be factorized. Furthermore, Sometimes we may use the result of the previous questions. That's the end of the lecture. Thanks for watching.